Good morning, everybody. Welcome to the second day of our Earth Observation Summit. This morning, it's all about the body of knowledge for Earth observation and geospatial information. We will start with Danny Vandenbroucke from Spatial Applications Division of KU Leuven, who will explain the what and the why about our ontology-based body of knowledge. After that, I will explain how it is developed within the EO4Geo project. So how we are developing it, how we are filling it with concepts, skills, and so on. And the third presentation will be given by Rob Lemmens from ICT from the University of Twente, and he will demonstrate the tools that we use to navigate the body of knowledge and how we maintain the body of knowledge. That's for this session, and in the next session we will still be talking about the body of knowledge, but there we will show what tools are used to exploit the content of the body of knowledge. So I hope you enjoy this morning, and I pass the word to Danny Vandenbroucke for the first presentation. Thank you.
Welcome to everyone. I will talk now in this first presentation in this morning session on an ontology-based body of knowledge for geographic information and Earth observation that we are currently working on in the context of EO4Geo. I'm Danny Vandenbroucke. I'm working at the University of Leuven, a Spatial Application Division, and I will walk you through this presentation. What's the outline of the presentation? First of all, I would zoom in a little bit on what we mean with an ontology-based body of knowledge. Secondly, I want to tackle the issue of what we cover in the body of knowledge. What is the professional domain that we cover with this body of knowledge? I will go very quickly back also to the history and the background of this body of knowledge, but most or biggest part of the presentation will focus on what we mean with concepts in the BoK, and especially with some examples I want to illustrate this. And then before having some conclusions, there is also a short section on how we eventually can link in the future to other BoKs and other ontologies. A body of knowledge is in fact a formal description of a professional domain. I will explain later on what the ontology means, but you can see at an ontology-based body of knowledge as a kind of mind map illustrating all the concepts that you can imagine describing your field, your domain, your profession. It's in the form of graphs, but it can also be in the form of descriptions, abstracts. You can link it to papers or books or other information about particular aspects of your domain. We will also come back to this graph form to manage and to represent the body of knowledge. Now, if we speak about a certain professional domain, then we wonder what is covered by the geographic information and Earth observation science and technology domain. In this picture, you see in the middle our domain in the strict sense of the word, which will cover on the one side scientific elements, which bundles the scientific insights based, of course, on research done over a long period of time. But it's not only about scientific insights and the real fundamental science behind, it's also about the related technologies. And the technologies can be very broad. It can go from software to certain elements that can be used to collect information in the field, etc., etc. And then you have a third pillar in the domain, which is maybe even more important, which are the applications. Usually, of course, we develop, we use scientific insights and technology from our domain in particular areas to solve real world problems and to visualize those, to process information, to get answers to certain questions and so on. So the application side has always been very, very important in the GI and Earth observation domain. Now, as can be seen from this picture, the GI and Earth observation domain is not to be seen in isolation. On the contrary, I think it's quite particular for our domain that we are linked to a lot of other sciences, more fundamental sciences that you can see on the left side, going from philosophy, psychology. You would not imagine that there is a link there, but to give just one example, for creating maps, there are some psychological insights on the use of color symbology for creating maps, for example. More obviously, mathematics. For a lot of GI and Earth observation data handling, we need algorithms. There is a lot of mathematics in general in there, usually also in the software that we use. But in general, the Earth itself is described as a mathematical model. And not only mathematics, also statistics is linked there. Physics, which is also of particular importance for Earth observation, Copernicus, if we speak about the space components, for example. And then computer sciences or informatics in general. You can't decouple, let's say, our domain from everything related to ICT, to informatics. But there are also links to other more particular scientific domains, but also technologies. Technologies that emanate from activities in engineering, in space. Of course, for Copernicus, the space component is very important, although that in EO4Geo, we focus more on the downstream aspects. So the data, the services that can be used in different contexts and in different applications. But the link to space and the space component remains there. And as I said, also the general insights in information science and technology are very relevant. The GI and Earth observation domain did not invent new approaches, new methodologies, new technologies from scratch. We rely on what is happening in these other domains. But then you have also other domains like geography, architecture, geology, for architecture, landscape architecture, etc., etc. So there are quite a number of fields that are interconnected with our professional domain. And then at the bottom of the figure, you can see that since we focus a lot on also on application of the technology and the science in our domain on particular cases, the application domains themselves are also of utmost importance. And there are a few mentioned here in the slide, but there are of course a lot more, going from agriculture over climate, transport, mobility, security, disaster management, etc., etc. And also cross-domain application domains like agro-environment, for example, or smart cities, which is a mixture of different domains, are more and more important. Now, the question is, what does that mean for the BoK? So do we cover with the BoK the geographic information and Earth observation, science and technology in a narrow sense, or do we look at it a little bit broader? And then you can see here the dotted line. So it's not only in the narrow sense that we will look for in the BoK for the GI and Earth observation domain, but we will also have these hooks to these other sciences and these other technologies, and also to the application domains that will be, in a certain sense, integrated. Now some background information of how we came up with a BoK for GI and Earth observation. That goes in fact back to more than 10 years ago, when a first BoK on GI science and technology with very few developments on remote sensing was established and developed in the US by UCGIS, and it was published as a book by the Association of American Geographers. You can see it to the right. It was in fact developed based on a request from industry that found many problems in finding the right people for job positions that had the right knowledge, skills, and especially the skills related to new developments, technological developments. So it was defined by a series of, or a group of editors and experts who together covered different knowledge areas, different domains, subdomains, and who defined together the BoK. So it was quite hierarchical. It was structured, so starting from 10 knowledge areas, and then splitting it in units and around 330 topics, so at the lowest level. But then in the years after, it was seen, we knew also in Europe that this was existing. But we found that this first version of the BoK was not used so much for many reasons, amongst others because it was quite static as a book, not in digital format, not updated. It was quite geography oriented, with a lot of influence also from the US, which is normal because it was developed in the US. And we knew that already almost 10 years ago, there was a huge interest in having something that is more dynamic, more focused on Europe, etc., to have that also for Europe. Interest came from Agile, ISPRS, and then there were first there was a project, LLP Erasmus, a project GI Need to Know, and then of course we have now continuous efforts from E4Geo to develop that further and to extend it to Earth observation, because the original version was really GI focused. Okay, ontology-based BoK, what does that mean exactly? As I said, we define in the BoK concepts. Here is one example in the left from a publication from Sean O'Hearn from 2013. Example is database administration is a concept. And then of course, you can link it or use it in training modules at university, in courses. You can link to it one or more references, and references have authors, etc. So the concept can be anything from a theory, a method, a technology, an application, a piece of legislation. It can be many things that are relevant to teach about in our domain. So the BoK will consist of many, many concepts. And particularly, what is important is that the concepts are not in isolation from each other, but are interrelated. Of course, not every concept with every other concept, but there's a logic in it. Also important is these concepts are not only theory, as I said, they are not only scientific, also the BoK aims to be used in practical settings. So it's also making the link to not only knowledge, but also to skills, and as I said before, to applications. So the concepts are described and also related skills to concepts are defined, usually in terms of learning outcomes that has been explained yesterday. And then we have references to many assets, let's say, like papers, books, tools, learning modules that are references and that can be used in the context of learning actions, for example. Now let's go and zoom in on a few examples. One concept that certainly will be and is already in the current version of the book is a concept of sensor web enablement. That's the starting point. Now, if we speak about sensor web enablement, there are two aspects in it, and so they refer to two concepts which are more generic, more general. Sensors in general should be understood by the students or by those involved. And in fact, in the context of Copernicus, also in situ measurements are quite important. So sensors for in situ measurement is a concept that should be explained. For example, when we talk about practical applications related to air quality monitoring, weather forecasting and monitoring, water flows, and in general, water management, noise monitoring, etc., etc. So we require sensors there, but also for doing sensor web enablement, we need the internet, the web. So we need some knowledge about basic concepts on the web technology stack, going from what is HTTP, what is service-oriented architecture, what are the standards from W3C behind, etc., etc. So this is like a link to higher level concepts, but then linked to those again, you might have many other concepts to explain in classes or in other contexts. And as I said, sensors can be many things. This is just an example of a weather station, but nowadays you find sensors everywhere, and it has been extended even to the people as a sensor, persons as a sensor through their mobile devices. Now, the sensor web enablement, you can then zoom into other concepts that are more detailed and that are interrelated. You should explain, or you can explain, sensor observation services that can make you, well, give access to sensor streaming, sensor planning services. And of course, all these concepts are based on what we call observation and measurements and techniques for collecting this type of information. So these are the different bubbles that are related to sensor web enablement. And of course, there are more because I could not put them in one slide. And at a certain point in time, this will generate maybe flows, and then the student might be interested to know how to use this data coming from the web, sensor information, and integrate that in real work processes and data flows using GI tools and applications. And there is one example here on noise to the right, where this type of information from sensors came up and was then processed in a GI environment, GIS environment, and then mapped against other information. Examples of skills required for or linked to those concepts are, of course, interpolation of observation and measurements. The setting up of such services can be a skill. The integration of services, sensor web services into applications is another example of a skill. So that's, let's say, one example focusing more on the technology. Another example might start rather the other way around, from what we call real cases, real applications, to which you can also relate skills or for which you can define skills. And one example here is monitoring floods and flood risks. And there we wonder, what is flood mapping? How should that happen? What does it mean? And of course, here we can make an interesting link to also legislation, so the background. So the students might need to know, why are we doing that type of flood mapping processes? And in Europe, it's related to the flood directive, the Water Framework Directive, the Water Information System of Europe, but also to the soil strategy and I will come back immediately to that. So flood mapping is a starting point. But again, there, in order to understand flood mapping, to be able to do that, you need to know the basics, and you need to understand the water cycle and water management principles. Of course, that are in fact two concepts in one bubble. You could split it. And you should be also aware, maybe not specialized, about hydrological and hydraulic modeling, which is not the same. Again, you could split that in two different concepts, while the hydrological cycle is more about how the water circulates in the air, going in the ground, runoff, infiltration in soils, and coming back. So there's a full cycle, that's one thing, but of course people are intervening in reality. So hydraulic modeling is more on the effects of sewer lines, drainage systems, dikes, etc., engineering aspects that should be taken into consideration. So if we speak about flood mapping, it's not enough to have a terrain model of the landscape. You should have different elements to be taken into account. And then, of course, flood mapping can mean different elements, different concepts, different ways of doing it. So each time you have one concept, and again, that's split again. For example, flood monitoring of real flooding by using remote sensing. But also the mapping of natural flood areas based on soil maps, for example. The modeling of flood risk areas, etc. So these combined will then generate an information system on floods and flood risks that can be used in disaster management, permit delivery, insurance cases, etc. And again, their examples of skills are, depending on in which area or sub-area you're active, is image processing, water modeling, soil interpretation, and the like. So that's more an example from the application side, which can also be defined in the BoK in different levels and different interconnected concepts. And the third one is more on data management, which is quite important in general for Copernicus, for spatial data infrastructures, where the focus of the concept could be on geospatial data specifications. How do we model our real world? And how can we do it in such a way that we have interoperable spatial data, that we can combine data together for integrated applications? And again, here there is a link to existing legislation at European level, going from the SPI directive, Aarhus directive, the Access Directive, Open Data Movement, the PSI Directive, etc. So we model our world, and there it's an interesting case to see how learners should look to concepts that are interrelated, because you have four interrelated concepts that goes from the modeling itself. And in order to do or to define a model of the world, you need to know something about conceptual modeling languages. Then you can make a data model or data specifications. Then you can harmonize or transform data, that they can be combined. And then you can do testing and validation, whether your data model is conform to specifications once you have done that. So there is a learning pathway in a certain sense. You can't understand the concept of geospatial data validation if you don't know what geospatial data specifications are, or transformations. So the order is important. And therefore, conceptual modeling languages, it's not necessary only to know theoretically what it means, but you need also to be able to do something with languages that exist to do this modeling. Again, there you have different concepts with respect to geospatial data interoperability. They are related to each other, and the training should follow a logical learning path. And at the end, you will be able to integrate all these harmonized data in a GIS for different applications. So that were the three examples. Now, before I end, a few words on what will we now at the end do with this BoK? Of course, you saw yesterday already that you can or will be able to rely on it for curriculum design. But in reality, you could develop more tools or have more applications where you use the content, the concepts of the BoK to do program accreditation, certification, issuing of certificates, screening of employees, job offer descriptions that will be tackled later today, the definition of occupation profile also on the agenda of today as examples. But you can imagine that you use the BoK for many other things. For example, to describe past, ongoing, future, the agenda, research agenda, and research projects, also documenting work processes and activities. So in principle, you could use it for many interrelated things. And of course, you will not use everything in the BoK. If we speak, for example, about the learning path, then we will walk through the BoK, to say it in certain, in an image, where the learner wants to reach certain outcomes, and then you need to visit different elements of what is in the BoK. Now, as I said, the BoK and our domain is not in isolation. So it's not very surprisingly that there exist other initiatives, and the most important one is the Earth taxonomy for the particular sector of remote sensing and Earth observation, which will be linked and integrated in reality in our BoK in Geo4Geo. But many others in our domain are also working on particular BoKs or ontologies. For example, ESA for space component is developing an ontology. You have a new version of the US GIS body of knowledge. You have one from the International Cartographic Association, so zooming in more on cartography. The OGC is also developing its own BoK. There is a BoK for surveyors, etc. And then there is existing BoKs in other domains like project management, business analysis, ICT, data management, software engineering, etc. So we can rely, at least for the content, on these BoKs because they are not really operational to link to them physically. And there are also vocabularies like the ESCO vocabulary on skills and occupations, and other vocabularies, for example, related to Inspire that can be cross-linked. So we think that we will evolve towards interconnected BoKs and ontologies. And with this slide, I want to end my presentation. So the ontology-based BoK for GI and Earth observation forms the basis for the Geo4Geo activities in the short term now, but also in the long term. It helps defining our professional domain through a kind of common language, linking all these concepts to allow easy definition of skills, curriculum design, and etc. Important is to understand that this BoK must be dynamic, all the time changing, enriched, modified. It's a collaborative effort. There's no one single editor that can do this. It's in a certain sense never finished. So it requires input from many, from the communities. And it should take into account technological and societal trends to include and embed them. And of course, it should be also kind of operational, and we will see that in the next presentations. It needs a technical and a platform and environment that can host it, that make it, or that allows people to access it. And so the next two presentations will zoom in on those aspects. So how this is really populated and how the tools are used. And with that, I want to thank you.
Good morning, everybody. I'm Marc Olijslagers from the Spatial Applications Division of the KU Leuven. In this presentation, I'll explain how we are developing the body of knowledge for GI and EO in the Geo4Geo project. This gives a short overview of what I will cover in this presentation. To begin with, where we started. Then I will explain how we organize the work in working groups and how we built a network of experts to help us develop the body of knowledge. In the development of the body of knowledge, the first step is the identification of the concepts, and then we started elaborating them and creating relations between the different concepts. I will also shortly explain something about the versioning system that we developed for the body of knowledge, and I will explain and show some of the challenges that we meet in building our GI and EO body of knowledge. So where did we start? As Danny explained in the previous presentation, we didn't start from zero, but the existing body of knowledge was mainly focused on GI, and there were only limited number of Earth observation concepts present. So within EF4Geo, we add a detailed Earth observation part covering all aspects of Earth observation. We also have a look at the market-oriented view, where we focus on the user uptake, because this is an important door to the body of knowledge for industry and for people on the user communities, and not only on the academic side. So we organize the work in working groups, and these working groups more or less mirror the way we started. The knowledge areas from the original body of knowledge are arranged in 3 working groups. Working group 1 focuses on methods and foundations. Working group 2 on visualization and GI system. And working group 3 on spatial data infrastructures and related concepts. Then we add 3 working groups related to Earth observation. And these working groups are divided in a working group 4, which covers the physical principles. Working group 5 covers platforms, sensors, and digital imagery. And working group 6 covers image processing and analysis. And then, as already explained, we have a 7th working group which focuses on thematic and application domains. So this is the market-oriented view. It covers user communities, societal and environmental challenges, thematic areas, and products and applications. So this is really looking at it from the uptake side. We have a network of experts that we are building, and these experts help us in developing the body of knowledge. It's very important that we have the involvement of the geospatial community, and by involving the experts, we hope to get there. We stimulate discussion, but of course we hope that this always ends in a consensus on the content of the body of knowledge. And in this way, because the community is engaged in the work, we will create a body of knowledge that's supported by this community. It's also important that we focus both on academic and on the industrial perspective to make sure that also those sides of the geospatial community both can work with the body of knowledge. If you're not yet engaged in this network of experts, our call for experts is always open. It's published on the EF4Geo website. You see the link at the bottom of the page. I really invite you to visit this site, to fill in the form, and to participate. So what's the current status of this network of experts? Currently there are 164 members, and because an expert can participate in several working groups, this results in the number of experts per working group that you see in this image. You see, for example, that working group 4 on physical principles for Earth observation has only 19 experts, which is quite a low number. So there are experts needed everywhere, but especially in that working group. We also want to have experts from academia and industry in all working groups to be sure that we not only cover, let's say, the theoretical view on concepts, but that we also cover the real world use of the different concepts. Experts can contribute in different ways. Some experts really discuss the concept descriptions and write them themselves. Other experts prefer to review concepts that were already elaborated by others. And some experts focus on specific things like the skills related to the concepts, or maybe they have a more bird's eye view on the body of knowledge, and they look at the concept relations in between or over the boundaries of the different working groups. Now, in the work itself, the first step was the identification of concepts. In this first phase, there were about 35 experts involved. For the GI part, we started from the concepts which were present in the GI body of knowledge. These concepts were assessed. We looked at which ones are deprecated, which ones are missing, but also for the others, we did an assessment about what work is to be done on these concepts to finalize them and to get a final approved version of them. For the Earth observation concepts, the work really started from zero. So discussions under the experts resulted in the 3 working groups that I named, and each of these working groups has between 150 and 220 concepts. So there's a lot of work to be done there. There's also the working group 7 on the uptake. The structure of that working group was elaborated in close collaboration with ERSC and also with the COPHUB program, which is also focused on user uptake. So this is where we started from. It in total it's 1,175 concepts, but this is not a fixed number, it's dynamic, because in the elaboration of the body of knowledge, we will merge several concepts. We will have a different look at the level of detail that's needed. Sometimes we will remove concepts because the level of detail is too high. Sometimes we will create new concepts to get especially a step deeper in level of detail. There's also very often discussion about concepts. Do they belong inside the body of knowledge, or do they belong to another domain? And then, of course, even for concepts that are already in the body of knowledge, but also for emerging technologies, everything is evolving so fast that in the 4 years of the project, new concepts will arise on the horizon. For the elaboration of the concepts, we work in the living textbook environment developed by ITC from the University of Twente. I'm not going to go deeper into that because Lemmens from ITC will do a live demo of this in the next presentation. Each working group has a working group leader, and these working group leaders guide the process. They invite experts to write, to review, to comment on concepts, and so on. They also steer the communication between the different working groups. They look at redundancies, at relations between the working groups, and so on.
So these working group leaders have regular meetings where they discuss the progress, but also the cross-working group issues. For the experts, we have guidelines which explain how things are done. So these guidelines ensure that over the different working groups and for the different experts that we reach a uniformity in the development to make sure that concepts all are in the same format and have the same level of detail in their content. We also have an editorial board, which also, of course, guards this overall format and the quality of the concepts. They also look at the content of the concept, and if needed, they invite external experts for a peer review of the content. The editorial board also has this bird's eye view where they will look over the borders of the different working groups, and they will look at redundancies which are missed by the working groups themselves. We also get a lot of feedback from the people who are using the body of knowledge related tools. At the moment that they are developing curricula or working on job profiles and so on, they will indicate which concepts are missing, which skills are missing, and are often used in the real world in job descriptions and so on. So we get this feedback from the tools, and this will be incorporated in the body of knowledge. So where are we now? At this moment, the identification of the concepts is already done, and these concepts all have a short description and they have their first relations. Thanks to that, we have first structure of the body of knowledge, which is important to be able to navigate through it in the different tools. For the complete elaboration of the concepts, about 10% of the concepts are finished. They still have to be approved by the editorial board, but we are at 10% more or less. The working groups are fully in action, especially since we switched to the living textbook. Things are accelerating, which is also a must because we still have a lot of work to do. And at this moment, because we also want to use the tools for work on curricula and on specific use cases, we give priority to concepts which are used in these use cases or curricula, which are under development in the ER4Geo project. This means that different concepts at this moment are in a different stage of development, and therefore it's important to know that the tools will indicate the status of the concepts. So you know if you're looking at a fully elaborated concept description or if it's only the first short description that was given by the identification of the concept. We also work on the relations between the concepts, and this is very important because by creating new relations we get a better integration between the GI, the Earth observation, and the uptake part of the body of knowledge. Relations also add intelligence to the body of knowledge. It tells us which, for example, prerequisites you have for curricula. If you want to know something about a certain concept, you first need to know something about different other concepts, for example, or if you have some application, it will indicate which technical concepts are used in that application. It's important to know that due to the ontology-based approach, our body of knowledge is much more than just a hierarchical structure of concepts. For example, in the image you see, maybe the arrows are too small, but this concept has more than one incoming and more than one outgoing relation. So even the relation of being a subconcept of something can be double. So the same concept can be the subconcept of two or more superconcepts. Okay, because we are working on the body of knowledge with our experts, it's important to know for you as a viewer, not as an expert, but as a user of the body of knowledge, how the work of the experts is propagated to the tools. And for this, we work with a sandbox and a master. In the master, we have the approved concepts, and this is what you see when you use the tools. Okay, so it's not that it's only the approved concepts. If it's not approved, you will see the status of the concept, but these have a fixed status, and the experts, they discuss the concepts for the work in progress in the sandbox. In the sandbox, you also have feedback from the editorial board, and in the sandbox, extra information can be added and it will be preserved for future use. And at a certain moment, we will decide that we want to release a new version, and at that moment, we create a copy of the sandbox. This intermediate version is then checked and cleaned up. And after that, this intermediate version is copied to the master. So this becomes version n+1, while the previous master version is archived as version n. And this archive is accessible through the versioning system that is built in the different tools. Okay, working on this body of knowledge has a number of challenges, and the first challenge you see in this image, this is an overview of all the concepts and relations at this moment defined. So it's more than 1,000 concepts. So the work to be done is huge. Again, please collaborate as an expert. A second challenge that we have is the integration between the different parts. So this was the starting situation, as I explained, but of course, by creating new relations, by merging concepts and so on, we want to have these three different entities more and more integrated until we reach really one body of knowledge where you don't see these boundaries anymore. Another challenge is that we have to marry the viewpoints of academia and industry. This is very important because only in that way we can make the link between the two and making sure that academia delivers the knowledge and the workforce that is needed in industry. Is one of the important goals of the E4Geo project. So it's very challenging to define the concepts and to name the skills related to them in a way that's satisfying for both the academia and the industry. But within the project, we have very fruitful discussions and very interesting discussions on this, and I think we make very big steps here. So I think this is very important that this marriage works, and within the E4Geo project, I think we are reaching that. Then there's the challenge of where are the boundaries of our bodies of knowledge. This is a difficult discussion, which is sometimes met again on different concepts. So what belongs within our body of knowledge and what doesn't belong inside of it. We all know that the geospatial world links to different other domains, and that we use technology from other communities. So we use concepts and knowledge from outside our own domain. So how do we integrate this in the body of knowledge? It's not only about technology, but it's also about transversal skills, for example. All these things are important. If you create a job profile using our body of knowledge, you know that a job profile is not only about geospatial technology. It will also be about management skills. It will be about informatics. It will be about certain domains like forestry or agriculture. So we need to have this link also. So that's content-wise a challenge, but also technically, how can we implement these links in a platform? We also have within our own domain, so in the Earth observation and geospatial information domain, we already have existing ontologies and taxonomies. There are new ones developed. So again, we are not alone on our island, even on our side of the boundaries. We need to be able to link, to copy, to adapt information from other ontologies. We also need to strive to cooperation to make sure that work is not done twice, and to make sure that different systems, ontologies can work together. And both for connection to inside and outside our domain, we need to look at accessibility, because often we see that ontologies and so on exist, but that we cannot access them because it's technologically not possible, or because we don't have the right for it. Overall, geospatial world is interwoven with a number of aspects in society. So we want to have links between our body of knowledge and those other aspects of society. And the last challenge is, of course, the fast technological progress in the world. New technological or societal trends need to be followed. We need to be able to identify new trends and concepts related to that, and we need to be able to decide when it's time to integrate new things in the body of knowledge. And also concepts that are already in the body of knowledge, it's important that we keep looking at them, because there's a very rapid evolution. So even existing concepts have to be monitored constantly to be sure that they're up to date. Okay, thank you. I hope that now you understand how we are working. And in the next presentation, Rob Lemmens from ITC from the University of Twente will demonstrate the tools that we use in this maintenance and the elaboration of the body of knowledge. Thank you.
Hi, my name is Rob Lemmens and I work at the University of Twente, Faculty of Geo-Information Science and Earth Observation in the Netherlands. And I'm very happy to show you how we edit and visualize the EO4Geo body of knowledge. In the EO4Geo project, we create a range of tools around the body of knowledge. Tools to create and visualize the body of knowledge, as you see here in the circle, the inner circle, and tools for end users with which they can create curricula, occupational profiles, and job offers here visible in the outer circle, and all of them are interconnected via the body of knowledge. In this presentation, we actually concentrate on the inner circle. So which tools are used to create the actual BoK and the concepts in it, and how to visualize them. Basically, we'll highlight two tools here, the Living Textbook and the FindinBook. The Living Textbook tool was originally created for education and knowledge transfer and is used at our university in several courses. It supports the creation and exploration of information with the help of a concept map, as you see here on the right hand side, and a text window with hypertext and learning paths here at the bottom, in which you can consume the content of the knowledge items in this study area in a sequence. And the concept map is actually a tool to do what we call non-linear learning, so that you can jump from one concept to the other and also consume the content in another way than just a normal book. The Living Textbook is now the main BoK editor for the EO4Geo project, and it works in a collaborative way. So you can create concepts, their content, which is then expressed here on the left hand side for each of these concepts that are indicated by these circles. And you can create relationships between these concepts by means of arrows and labels. It actually follows the principles of linked data. So each concept is connected to another concept, and you read the connection with the arrow in between as a sentence. So for instance, this concept is a subconcept of this concept. And there are also other relationships possible. With the same tool, we can also do commenting on text that other people have created, like you see, for instance, here a note. You can search with, for instance, this button, and you can export the content of this knowledge area to other tools, which is also done in the EO4Geo project. And all in all, we can also perform user management, so that we can say, okay, there are certain viewers to specific areas of knowledge, and there are also editors. All of this we will show you also in the other part of this presentation. The other tool that we demonstrate in this session is called FindinBook. And this tool can be used to visualize the same content as is created within the Living Textbook, but then in another way, and it's also versatile in the sense that it is used as a module in other tools. So the other tools that were also mentioned already, like the job profile tool and the curriculum design tool, can use the visualization that is shown here. The concepts are shown in a different way, in a more hierarchical way, so the circles in circles, which show the sub-concepts. The tool also displays similar information as is done in the Living Textbook tool, and it also supports permalinks, so we will be able to show the different versions of the different concepts in the different versions of the body of knowledge. An important thing to know is that we have different instances of the body of knowledge. We work in a so-called Sandbox, in which we actually do the work in progress. And we, on the other hand, also have what we call a Living Textbook Master. And this is the official version that is used outside also by the other tools. And we do have a versioning process in which we, in each versioning cycle, we copy the Sandbox into an intermediate version, intermediate instance, and we clean all the things that should not be there, and then copy it into the official version. It's important to know that what I show you in this presentation is the Sandbox. So this is work in progress. There are concepts that are not cleaned. There are also concepts that are not completed. But you can see a fairly nice overview of what we are currently working on. So this is not the official version that is used. but we will come back to that. Okay, now let's have a look and have a short demo on the living textbook. So what I will show you is the Sandbox, as I talked about. So I open it here, and the first thing that I see is the dashboard, in which I see the number of concepts, number of relationships, the contributors. So this is a kind of metadata window, and I can only see the concept map when I say open map, and there it is. So I can drag the windows a bit back and forth to concentrate more on the text or concentrate more on the concept map. I can zoom out so I can see the full body of knowledge, but not in detail, and I can zoom in here. Nice thing to see here is that the ones in green, they are the finished concepts, well, or in progress, I should say. The gray ones are just the ones that are entered with the title and do not have a description yet. So you can already see here the work in progress. The interface works like this, that if I zoom in, I see all the concepts and the arrows, but I don't see the details of, for instance, the arrow labels. Once I move over one concept, I can see the concept itself plus its first order relationships. So the ones that are only in the vicinity of that specific concept. So let's take this example of this concept, along track scanners. When I click on it, I can actually see the text here on the left hand side, and I can read about what it is. External resources, so the references that were used to actually create the content, and I can see here that it's a completed concept. The relationships here are the actual arrows that we can see here, and what we do see is that along track scanners as a concept is a subconcept of line detector arrays. I can also go to line detector arrays then, and I see that that is a subconcept of optical spectrometers. You can also see that all these concepts have codes, and these codes are the codes that we use to create the hierarchy and also to divide the different concepts into different categories. So this is a good example of a new concept, a Earth observation concept that has been added since we started EO4Geo project. There are also other concepts that more relate to the GI part of the work. Some of these concepts have been imported also via other projects, a previous project, GI Need to Know. And we are also working on these concepts to improve them and also to add missing concepts. So let's have a look at a specific example of this. So here you can see also that we have a search interface. So let's try to search, for instance, for cartography. So we have here a cartography and visualization concept. And you can see that this search also does an autofill. So whatever you type, you will get the concepts that contain the characters that you type. So we can go to that concept. We can zoom in a little bit here and move the map, and then go to that specific concept. Cartography and visualization. So here's the text description. I can zoom down a bit. Again, the external resources, I can also click on them to see them. And here's also an interesting thing. These are the skills and learning outcomes. These are the skills that are needed to actually master this, the content of this concept. So I can click here and then I see that specific learning outcome when it comes to courses, and skills when it comes to job profiles, for instance. So the skill here is choose from different options to create a map. And here I can see the actual content of the concept again. So these two are very closely related. If I click back on the concept, and I see again the content of the concept, which has been created for this particular area. I can zoom out again, and I can again go to other concepts like usability, which is then a concept of cartography and visualization. I see that it takes a bit longer today to load the content. Normally, I must say, it's quite fast. Now I want to show you another facility that we have. This is the more powerful text search. So I go to this window and I want, for instance, to know, okay, everything with image analysis, images processing, and then I can see throughout the text every concept where image processing is actually mentioned. So let's see, image processing analysis, for instance. I can go to that concept, open the map, and it will go to that specific concept here. And then from image processing, I would like to look at image pre-processing. And from there I see an interesting concept, which is image enhancement. And let's now try to connect a new concept to image enhancement. So we can do that by saying add. And what I want to do, for instance, is to add a concept that is called contrast stretching. So I create a new one here, and I give it a new number, and then I save it. So it has been added, and I could actually go and look at it, open map, and then it's there. It's still gray. So what I need to do is to enter a definition. Okay, let's copy this one that I've prepared here. Copy, paste it there, and save it. Then it has a definition, and then I refresh this map, and then you see it is now colored green. But what I still have to do is to connect it, because it's still now out there in the open and no connection. So I edit it again, and then I say it should have an outgoing relationship. It's a subconcept of, and then let's say image enhancement. Image enhancement. I say save, and you can see the relationship there. I refresh the map again, and then now you see that this one has been connected. I have to zoom out because it's quite far from the actual concept. And this is image enhancement. What I can do is to get these a little bit closer, and now you see that my concept of contrast stretching is a new concept, and is a subconcept of the image enhancement concept. Okay, now I've added the concept, and I just want to show you two more things. So one is the facility of making annotations to the text. So what I do in this particular content of contrast stretching is I select this particular text here, and I say create note, and I can say okay, just added this, please improve, and then I can ask this to colleagues and say okay, in this case everybody, say add this, and then you see that there's one comment here, and this is then a note for the other editors to take action. And the last thing I want to show is the export function. So there are several other functions that we have available, but we do not have the time to show them all. Here, for instance, you see several ways to show only concepts, show learning paths, external resources, and so forth. With the data menu, I can also make duplicates of this particular body of knowledge. We can also do tracking of the changes, and this is particularly interesting, an export function where I can choose between the different formats here. I can also export in a semantic web format, JSON, linked data format in RDF. But what we use now to export to our other tools is this particular format where we export all the concepts, the links, external resources, learning outcomes, and now also contributors. This will be then exported into an XML file, which can then be taken by other tools to incorporate the content of the body of knowledge. Okay, and then carrying this export to one of the other tools. Now I'm going to show you the FindinBook tool, which actually makes use of the export that I just showed you, which comes from the Living Textbook. So here we have this FindinBook tool, which I showed you already as a screenshot on one of the slides. So here you see the same concepts that we find in the Living Textbook, but then visualized in another way, more in a hierarchical manner. So circle in circle means a circle within another circle is a subconcept of that bigger circle. So again, what we can do here is search. So let's search for the same one that we had before, cartography, and also here this is an autofill. If I say carto, then it will just show 25 results, and these are also highlighted with thick boundaries in this visualization. So let's go to cartography and visualization, and then it zooms in, and here you see the subconcepts. So I can go and then look at subconcepts of subconcepts. I can go back again. It works quite nice. And here I find a description which is quite elaborated. And the nice thing is that I can also look at previous versions of this concept. So I scroll down and I go, for instance, to a version before, and then I see that the description is also shorter. So the enhanced one is in the later version. Here I also get a warning that I'm looking at an older version of the body of knowledge. So of course I would like to go back, and then I see the current version again of the concept. So again, this is an interface to browse and explore the concepts in another way. And the same visualization is also used in other tools to select certain concepts also based on their content. Now that you have seen the working of the Living Textbook tool and the FindinBook tool, I like to come back to this versioning process. What you have seen is the body of knowledge in the Living Textbook and the FindinBook. That is the Sandbox instance. There is also the master instance, as I have highlighted in the beginning of the presentation. This is the version that is used by the other tools, and it's also the official version that is published to publicly. So we also indicate the concepts there that are completed. In the Sandbox, actually, there are also concepts that are not completed because it's work in progress. The Sandbox is normally somewhat bigger because there are all kinds of, let's say, comments and extra information. The master is the cleaned version, which is out there to be used in public. It's just good to emphasize this, and the process actually to go from Sandbox to master is done by an intermediate version, and the update cycle, typically maybe a few months or half a year, will be done through this process. But all of it is still work in progress. I hope that you have learned a bit of how we are creating the body of knowledge, how we visualize it, and I hope you enjoyed the presentation. Thank you very much.
Okay, welcome again, everybody. I'm here virtually together with Rob and Danny. We had some questions posted, so we'll try to answer these questions. The first question from Mary is about where are experts coming from, and is it focused on Europe? At this moment, if I look at the list of experts, a little bit more than 90% of the experts are from Europe. And of course, the body of knowledge sometimes focuses on European aspects like Inspire or Copernicus, but we surely want to engage experts from all over the world. We really want to have the whole community involved. For example, we also will take action to get the people from the UCGIS body of knowledge involved. Okay, second question, is the body of knowledge a sort of Bible and a platform for further researches? I'll pass that to Danny.
Okay, thanks, Marc. I don't like to say that it is a Bible, but we consider the body of knowledge a kind of motor, at least for all our work. So when we speak about curriculum design, but also technically speaking, all the tools are connected to the BoK. In a certain sense, it's not a separate platform. It's a repository of all these concepts that are used through the tools by many different types of users, users that want to design curricula, companies that want to create job offers, etc. So it's I call it always a motor of an ecosystem rather than the Bible. And of course, content-wise, it's the result of discussions amongst experts, but there is not one truth. So there might be new concepts, there might be discussions, new discussions, there might be adaptations, etc. But we hope that it will be reused by many. So also the idea is to make available APIs so that other developers also can develop other tools on top of it. So in that sense, we share it, and we will hopefully reuse it also in the context of the description of research projects and other activities. Thank you.
Okay, thank you. So we don't only share the content of the BoK, but also the tools that are used there. Okay, we have a question from Estefania who asks which kind of experts we are looking for, and is there a filter on experts? I'll pass that to Rob.
Yes, thank you, Mark. Yeah, we actually do invite experts from industry and academia, so there is not such filter. Although we, once you register, we ask you for some, let's say, background information, for instance, a link to LinkedIn also. And we use this to filter for which concepts are possibly relevant for you to provide content on. So in that respect, we do actually like to choose the experts to fit at specifically the right places.
Okay, thank you. Another question about the experts that I see. I'll pass this question to Danny. Is there a way that experts are recognized or acknowledged for their work?
Yes, that was a topic of discussion in the context of the consortium and the work of the EF4Geo. Of course, that's not an easy one because some of the experts are not part of the members of the consortium, so they are not paid to do the work. Of course, there are also experts from the different partners. They do some work, but to support the other experts, we acknowledge them, and in fact also those from the consortium, by putting their names on the website of EF4Geo, of course with their consent. If they don't want to appear on the website, they can say so. So that's one way of doing it. Another way that we want to experiment with, rather, because we didn't do it yet, is to invite some of the experts, for example, to work jointly on one or more related concepts, for example, in the form of a paper or another publication that is of interest for all the experts involved, and that then can become, for example, a reference in the BoK, for example, as a paper that is published. And of course, we, in general terms, we will thank and already thanks all the experts that are actively involved, because without this network, we would not be able to do that. And we will, as I said before, we want to extend it systematically.
Okay, thank you. Well, and if we talk about extending, what about the body of knowledge if the EF4Geo project ends? Is there a plan to get it going after the end of the project?
Yes, indeed. Not only for the BoK, in general terms, EF4Geo wants and develops a long-term sustainability plan for the medium, intermediate, and long term. So we do not want to develop tools and the BoK, and then after the project lifetime, it's there and it's not maintained, updated. So one of the issues we are looking into is how we can moderate and animate this network so that new concepts are added also in the future, fine-tuned, modified, that material is added, new references, etc., so that it's something that is living. Because as I said in my presentation, a BoK that is in the form of a book or is only static, even if it's online, that's not very useful. So we are currently looking into mechanisms to do that and to guarantee financement, but also the governance of these issues and the way we can do this technically speaking.
Okay, thank you. There was one practical question. Are these presentations available online? Well, they will stay available until somewhere next week on the platform of the summit. But after that, we will also make them available on the EF4Geo website. And on that same website, we will also add the presentations themselves in case that the resolution of the presentations live was not high enough. And maybe related to that, I can invite you to get involved in the EF4Geo project. Again, you can go to our website. It's see the link here. There are different ways to get involved. You can join the alliance as a company, as a public organization, and so on. You can also join as an expert for the work on the BoK, to revise the BoK, to feed the BoK, to give feedback, but also to give new ideas about how the BoK can be used, of course. You can follow the project by subscribing to our project newsletter or to connect to our Twitter and Medium accounts. So we really invite you to connect in all ways possible and to get your input and your feedback. We are also developing training actions. We are developing the tools. So once these become available, we are really inviting you to participate in these actions. So please contact us through the website if you are interested in participating in these actions.
I see that there are 2 more questions.
Okay, we have 1 minute, I think.
No, a little bit more, a few minutes.
Okay, is there a public version of the body of knowledge available? And if yes, how can it be accessed? If not yes, when will it be available? Maybe Rob, you can answer that.
Well, there is, as we discussed, a master version, but that is not, let's say, openly available outside the project yet. And that is because we did not yet release the master as on the basis of what we discussed before on the Sandbox version. So first some cleaning has to be done, and then we can release that first version, and then it will become available.
So that will be end of June, maybe July.
Yeah, I think we agreed amongst the steering committee, in fact, yesterday, that officially when the BoK will be released and finalized as an intermediate version, because we will continue to work on it, of course, during the project lifetime, then it needs to be become a master so that the tools can work on this new consolidated version. And maybe linked to that, we have to mention that we not only work with the experts, but also that we have a kind of editorial board that reviews the ones where there might be some discussion prior to release and acceptance. So we currently are looking into to have an extensive or a more extended editorial board with experts that are not involved in the development of the BoK, but that can contribute to kind of quality assurance process. So to have a stamp on it so that once we publish it, we are sure that it's of high quality and that the tools we work on this consolidated high quality version. That's basically the idea.
Okay.
So, because I think there was another question also on the certification of the experts. So
okay.
we will not do that.
We will have to end here. Please join the next session because there it will be explained what we really do with the body of knowledge, and questions that were not answered yet, we will answer them in written online. Okay. Thank you for your attention and please join the next session.